This is Geometry, section 9.1, translations. So before we talk about translations, we're going to talk about what this chapter is about in general. So in this entire chapter, we're going to deal with something called isometries. And an isometry is a transformation of a shape, any kind of shape, that moves it, but does not change it. Okay, so it's something that just moves a figure or a shape, but it doesn't change it in any way. So an isometry preserves or does not change the following. So it doesn't change the side lengths of the shape, those stay the same. It doesn't change the angles. So in other words, the shape is still congruent to the original shape that you start with. And it also doesn't change what we call orientation. So that's just if I take a shape, A, B, C, D, and I rotate it, for example. So I rotate it around this point and it becomes A, B, C, D, still the same thing. The order of the letters is still the same. They're still in the same order. So orientation is just a way of saying the position of the letters of the shape, if you were to name all the vertices of the shape. Okay, so for every isometry, we have a preimage and an image. This is pretty simple, but these terms are going to come up a lot. So the preimage is just the shape that you start with, and the image is the shape that you end with. Okay, so for example, this isometry or this transformation down here, this is our starting shape and it's turning into this shape. So we can tell that by the way the arrow is going. So this would be our preimage and this would be our image. Okay, so name the transformation. This transformation, what's happening here is this figure right here is just sliding across the plane to become this figure right here. So when that happens, we call that a translation, which is what this whole section is about. So a translation just means to slide something. Okay, so the preimage, like we just talked about, the preimage is this one, triangle MHA. The image, notice how it has these little tick marks with the letters here. We call those tick marks, or the way we say that is prime. So we would call this M prime, H prime, A prime. So the reason we use those is just so that we keep the letter straight. So M slides across and becomes M prime. H slides and becomes H prime. A slides and becomes A prime, and then we get the whole resulting triangle. So are these two triangles congruent? Well, if we look at the sides, this side, if I count this, this is 4. If I count this, this is 3. If I count this, it's 4. If I count this, it's 3. And since these are right triangles, if I use the Pythagorean theorem for each of these with 3 and 4 to find the hypotenuse, if I plug both those into the Pythagorean theorem, it's the same numbers, so it's going to give me the same thing for these third sides. So yes, these are congruent because all 3 sides are congruent, which we know as side, side, side. So as we said, this is called a translation. It's the first type of isometry that we'll talk about. So something that moves a shape but doesn't change it. So a translation is just where you slide a figure but do not change its size. Okay, so there's certain notation that we use for a translation. A translation moves every point, just like I said. We take M and slide it over here, H slide it over here, A slide it over here. So it moves every point by the same amount. We break it down into a horizontal amount and a vertical amount. So if we look at M to M prime, I can look at, okay, how far does it move horizontally and vertically? Okay, so if I break it into those two different components, it moves to the right 4 and it moves up 5. Okay, so right 4 and up 5. So we put those in terms of x and y because horizontally the x moves horizontally. This is our x-axis, and the y moves vertically. This is our y-axis. So we break it up into those two components. So for the notation for this example, we always write it like this, the x and the y, and then an arrow. So x, y, it's saying that any point x comma y turns into x. Well, what did we do to the x? We moved it over to the right 4, so we added 4 to the x coordinate. If we had moved it to the left 4, then we would have subtracted 4 from the x coordinate. Same thing for the y, we moved it up 5, so we added 5 to the y coordinate. If we had moved it down, then we would have subtracted 5 from the y coordinate. And these two notations mean the same thing, they just look different. So this notation, we use these triangular brackets, and all we do is we don't put the x's and y's in there, we just put the numbers 4, 5. So it's saying move the x by 4, move the y by 5. So this is the translation, or the notation for the translation above. Okay, fill out the table below and sketch the image of triangle HAT. So it says take each point x, y, add 2 to the x, add 5 to the y. So let's fill this out first. So all the x's, these are all my x's, so I'm going to add 2 to all of those because that's what the rule says. So -5 plus 2 is -3, -3 plus 2 is -1, 1 plus 2 is 3. Then for the y's, it says, okay, take the y coordinate and add 5. So I'm going to take all of these and add 5. So I get 6, 1, and 2. So if we do that over here, this really means, okay, we're adding 2 to the x coordinate. So we're going to the right 2 because right is positive. Same thing, positive is up for the y, so we're going up 5. So I can take each of these points, move it to the right 2, and up 5. So this would be h prime t, move it to the right 2, up 5. A, move it to the right 2, up 5. Oops, that's an A. Okay, so these points, these coordinates should match what we have on our table. And if we check them, well, h is -3 and it's up here at 6. That matches. And if we check these other two, they would match as well. For this table, now we're given both the figures, the image and the pre-image, and we have to figure out the notation, what the translation is, what the rule is. So first of all, we need to figure out, well, which is the starting one. The one without the primes, without the tick marks, is going to be the starting one. So here I'm moving this figure from here to here. So I have to figure out the notation. So coordinate notation is always like this. We'll do that for both of these. And component notation is with the brackets. Okay. So we have to figure out how far it moves over. Let's just look at B. So if I look at B compared to B prime, I'm moving over 1, 2, 3, 4, 5, and then up 1, 2, 3, 4, 5, 6. So to the right 5, up 6 means I'm adding 5 to the x coordinate and I'm adding 6 to the y coordinate, or components would just be 5 and 6. Over here, this is the one I'm starting with because this doesn't have the prime, so I'm moving from here to here. So P compared to P prime, I'm moving to the left now, 1, 2, 3, 4, and down 3. So left and down are both negative, which means from the x, I'm subtracting 4. From the y, I'm subtracting 3. So that would be -4 and -3 for the components. A couple more examples. So what are the coordinates of triangle J prime, A prime, R prime after these points J, A, and R are translated using this translation, this rule? Well, all the x's, it says subtract 8 from it. And all the y's, it says add 10 to it. Add 10, add 10, add 10. So J prime would turn into 7 minus 8 is -1, 11 plus 10 is 21. A prime, 2 minus 8 is -6, 5 plus 10 is 15. R prime, 17 minus 8 is 9, 1 plus 10 is 11. Simple as that. Do what it says to the x coordinates, do what it says to the y coordinates. All right, last example. If a translation maps 7, 13 onto 1, 3, then what is the rule? So component notation and coordinate notation, we have to figure out what happened here. So if we compare the x's, 7 and 1, I can ask myself, okay, well, how do I get from 7 to 1? What happened there? What did I do? Well, from 7 to 1, I subtracted 6. It went down. So I know I'm subtracting, and the difference between those is 6. Same thing from 13 to 3, I went down, or I subtracted 10. So components would be -6, -10, or coordinates would be x minus 6, y minus 10. And then for these, this one asks what's the image of the point 200, 300. So that means this is the pre-image. This is what I'm starting with. And I'm doing this to it. So I'm subtracting 6 here and I'm subtracting 10 here. So the result would be 194. Oops, 194. And 300 minus 10 would be 290. This one is trickier. This one says what is the pre-image of the point 4, 5, which means this is the image and this is the pre-image. That's what I'm trying to find. So now I'm going backwards. Okay, so I'm going to do the opposite of what it says to do here, because I want to go back to the starting point from the point that I have. So it's saying, okay, I took this point and it turned into this by doing this, so now I have to go backwards and do the opposite. So instead of subtracting 6 and subtracting 10, I'm going to add 6 and add 10. So 4 plus 6 is 10, 5 plus 10 is 15. So when it asks you for the pre-image, you need to go backwards and do the opposite of what the translation rule says.